Hi everyone, I am Sandhya, Department of Mathematics. Today we are going to discuss about the design thinking applied to elastic deformation in matrix materials. So in this matrix materials, exploring the innovative approach to the understanding and solving complex material behavior challenge to the human-centered design thinking methodology. So first we are going to see what is matrix. So in this matrix is a rectangle array of numbers arranged in rows and columns. If it is m rows and n columns, in this designing is a human-centered iterative problem solving methodology that transform the complex engineering challenges into the innovative solutions. So in this approaches deals with the empathizing the understanding user needs, defining problems, the clarity and developing the creative solution through the experimentations. So next one is the design thinking concept is first we are know what is the 5 stages of the design thinking. In this 5 stages are what are the 5 stages? In this 5 stages are empathize, define, ideate, prototype and test. So in this first we want to empathize. Here understanding the material behavior for the user requirement. So next one is define. So here we want to clearly for their mapping challenges. So next stage is in this ideate part, we have to generate innovative materials for the solutions. So the fourth stage is prototype. Here we want to creating testable materials for the specimens. So final one is we are going to testing. Here we want to iterate and validate for the performance. So next we want to understanding the matrix materials in the composites. Here continuous phases, the matrix form may be the continuous phase for the surrounds, and here we want to iterating and creating an fill composite structure with enhancing the mechanical properties. So next we want to discuss about the load transform. In this load transform matrix, here we want to critical load for the transform between the fibers product and for the environmental damage and the significantly influence overall the mechanical response. So next we are going to discuss about the design challenge. So in this key design challenges, optimizing the matrix composition to achieve the perfect balance between the strength and controlled deformation behavior. So here we want to the foundation for the composite performance, making the designing optimization crucial for the advantages for the engineering applications. So here we want to see this diagram. We want to how the matrix material is composites. Okay, next we want to discuss about the key concept in matrix in elastic deformation. Here first we want to discuss about the yield point. So in this yield point, the critical stress threshold for the permanent deformation beginning in the matrix materials, it is beyond this point for the material cannot return to the original shape, making the transform from elastic to plastic behaviors. So next we are going to plasticity. So here we want to critical stress threshold where the permanent deformation begins in this matrix materials. Here we want to choose the materials cannot return to the original shapes. So marking the transition from elastic to the plastic behaviors. So next we want to discuss about the identify failures modes. So here we want to analyze the matrix behavior under the real world condition, including the thermal cycling, mechanical loading environment. Here we want to combine stress states that lead to inelastic deformations. So next we are going to discuss about the understanding user needs. Here we want to manufacture require material and deliver the exceptional duality with the maintaining the lightweight characteristics and cost effectiveness for the practical implementation across the diverse of the applications. So next we want to define and the challenges. So how we can design the matrix materials that effectively in the elastic deformation. Here we want to while maintaining optimal performance for the characteristics. So next we are going to discuss about the third stage, that is ideal and prototype solution. So here we want to generate and innovative materials for the solution. So here we want to discuss about the explore modification and computational modeling and the create prototype. So here we want to explore modifications. So here we want to blend and nano filters and self-healing matrix system to enhance the deformation resistance. Next we are going to discuss about the computational modeling. So here we want to utilize and plastic simulation to predict in elastic behavior before the physical testing. So here next we want to discuss about the creative prototype. In this creative prototype we want to taking the sample and varied matrix in the formation for the testing and validations. Thank you.